Here you can see an example of a plate with several pockets, and one of the pockets contains an island. So we can all automatically machine those pockets. So we start selecting the pockets, the first one, the second one, third one, and counter direction for the island. So this will be in that direction, and we can move to NC jobs and start pocketing. Machiner Profile will just start answering the questions. Do we need a finishing? Yes, we do. Okay. Tensor will tell you which maximal tool you can use to remove all the material. So to finish we need a tool of maximum 12 mil. So this is just for information, so we'll move on. Would you like to load a new tool for this? Yes, we would. As we will first do our roughing, we will select a tool a little bit bigger than 12. So for example, we can select a tool of, let's say, flat end maybe 16 or 18, which is not present, but we can copy this tool and enter a value of 18, flat end 18, and we'll calculate the spindle speed. Click on OK and select the tool. OK. G55 is OK as our reference point, and the depth of our pocket is 5 millimeters. Start value of Z is 0. We'll do this in one step, and we'll leave an allowance on our profile of 0.2 with an overlap of 60%. OK. We'll use the spiral strategy. OK. And we'll, as strategy, we will choose the Z level, so that'll be 1. And we can, in this case, select, for instance, the helical milling. So we'll enter 1 here. OK. Our safe position, retract height, and you can see that the helical toolpath is now being generated, and we can define an extra rest material pocketing, which in this case we won't do, as we are planning to finish the pocket anyway. So we'll answer no, and we'll finish the profiles. We will use tool compensation, and we need to define a new tool. So we'll answer with, would you like a new tool? Yes. Start height 20, and we'll select a tool of flat end 10 in this case. Select. OK. G55 as our reference point, and we'll do this in one step with 5 mil. We'll click on OK. You can see the same questions appearing again for approach and retract height, and we will use an approach to finish it, and we can convert this into CNC code. As you can see, the finishing job is visible as you can see the approaches. We do not need any copies of this, and our toolpath is being converted into NC code. And this is our NC program, and if we want to simulate this, we can click on the eye. So Tens will make a copy of our NC program, and we can move to the simulator and click on the eye, and if we would like just one view a little bit bigger, so we'll click on OK, and we'll start the simulation. So this is our roughing of the pockets. As you can see, it's helical milling, and this is now being removed. And if you break into the program, you can see now it will load a new tool, and this tool will finish the profiles, and we'll click on enter, and our program has been simulated, and you can see the machining time using this feed is about 4 hours. So please move on to the next example to see how EaserTensor works.